Hello class, welcome to section 2.1. This is obviously the language of sets. The chapter 2 focuses, as you can see, on sets, set notation, things like intersection, union, and this section will introduce us to a lot of definitions and some of the groundwork to work with these kinds of concepts. So as I said, first a few definitions. Set, if you're not familiar with, is a collection of objects whose contents are what's called easily defined. It means that obviously it's very clear what they are. And those objects are also referred to as elements, or sometimes called members. So elements are members or objects in a set. Well defined means that obviously the elements are clearly defined. In other words, it's very obvious what an element is, what makes it an element, or what doesn't make it an element. For example, even numbers. Or if I say I'm going to make a set W, and it's going to represent the days in a week. So those are very clearly defined. It's very obvious what that is, and it's very obvious what it isn't, what it's not. We know Monday is an element of that set, Tuesday, Wednesday, Thursday, etc. But for example, a food, like a hot dog, is not in that set. And that's what it means to be well defined. It's very clear what is and what is not in the set. Now, as far as how to describe these sets, there are several ways. The first one is called a word description, which is pretty much what it sounds like. You just say, for example, set Y is going to be months of the year. I just describe it in words. So months of the year is set Y, simple as that. Another way is called roster notation, which if you think of like a team roster, it just means a list. It's a fancy way of saying list. So again, with my set Y being all the months of year, I'm going to list it out as January, February, March, April, and so on. Now in that example, I use the first letter, but however you would describe it is what you would put. Set builder is one of the more commonly seen ones, especially for those who come out of an algebra course. It's often used. It's a combination of both roster and word descriptions. And you can see here are three ways of writing it. So again, we're sticking with our set Y. Now you notice the format's written in. The first part of that, this is the first bullet point that I'm reading here under set builder, said X, and that vertical line means such that. I know it's a notation you might not be familiar with, but that vertical line means such that. So it's read X such that. And we have to pick X or some variable because we need to identify a general variable to represent any element within the set. Because what we're doing is first of all, we're identifying a variable. Now we're going to describe it to represent this set we're talking about. And X is the most commonly one used. You can use whatever you want though. So we say X such that. X is, now we're describing it. And here we can do it however you like, whatever makes the most sense. An element of Y is what we can say. So we say X such that X is an element of Y, where Y must have been previously defined. Or I could say X such that X is an element of the months in a year. Or purely symbolically, X such that X, and that little E looking symbol is an element of. It's a symbolic way of writing that. So we say X such that X is an element of Y, where Y is defined as the months of the year. So three ways of writing it. The common element though, or the common part of that you see is the X and then the such that. You have to identify what a variable is. And again, it doesn't matter. X is the most common one used. You can use whatever you want. But some variable to identify an element of the set we're talking about. And we'll work more with that symbol for is an element of in a minute. The universal set is a set of all elements under consideration, usually represented as a U. And I'll do that. Give you a better example in a minute. Some set builder notation. Again, it's naming a variable, arbitrary, and providing the description. So that's what we just went over. The empty set is a set, of course, with no elements, called the null set, written as two main ways of writing it. Brackets with nothing in between them. That symbol is the Greek letter phi. So either or, but you do not ever write the empty set as the symbol, those two brackets with the phi symbol in between, because that actually means we have a set with the symbol as an element. So again, it's one or the other. So some examples. Set A, where A represents the set of dog breeds with 10 legs. Or B, where X such that X are squares with 5 sides. So, empty sets, obviously something that has no elements, or something that cannot be. Another example of using set builder notation I wanted to go over is natural numbers, because that's one that's commonly used. So a way of describing that would be X such that X is a member of the set of natural numbers. And then you can modify that by saying divisible by 3. So I've taken natural numbers and I'm using set builder notation to modify it. Two more definitions, then I'll show you a couple of examples. Cardinality. It's a fancy way of saying how many elements are in a set, also called the cardinal number. Now notice the designation. In set A, some set A, doesn't matter what it is, the cardinality is represented by lowercase m and then the set in parentheses. That's a symbol for cardinality. So in other words, n and then A in parentheses means how many elements are in A. So for example, set A is a set of 1, 2, 3, 4, and 5. Then we say n, A in parentheses equal to 5, because that's how many elements are in there. Or set B, for example, is 2, 9, 4, 12, 44, 9. Then the cardinality of B is 6 elements. C, the element is 0. In this set there's one element, and that is 0, so we say the cardinality of C is 1. So all the sets that I've just listed are called finite sets, because of course there's a beginning and an end. Obviously an infinite set is a set where cardinality is not equal to a natural. In other words, equal to a natural number. In other words, this means there's an infinite amount of elements in the set. For example, the set of natural numbers is considered infinite because it continues on to infinity. So, a couple of examples. Again, let's review the notation, and let me make that bigger for you. That symbol looks like an E, is referred to as the element of the set. Write an element of, and then with the slash through it means not an element of the set. So again, going back to our example of months of the year, I can say January is an element of Y, and that's what that symbol means, because obviously January is the month of the year. Sunday, for example, is not an element, so we have the element symbol with the slash through it. That's how the notation is used. So if whatever is here on the left hand side, if it's an element of the set on the right, then we place our element of sign. Otherwise we place the not an element of sign. So for example, another one, I can say 3 is an element of the set here, 2, 3, 6, 0, and 12. Whereas I could say 3 is not an element of the set defined as Y such that Y is a set of even numbers. And again, I'm mixing in set builder notation. So again, two more examples of using the element notation. So for example, separate now, I want to say C represents the class of some class of math students. And I'm breaking down where M represents the males in the class, F represents the females in the class. We talked about universals. C is considered the universal because it contains all elements under consideration. So in this situation, we're considering males and females. The class is universal because it contains all elements under consideration. Now I know in the definition it said represented by U, usually. In this case, C is representing. Either way, C is still considered the universal set. So again, the universal is just everything that's under consideration. Another one, for example. U equals 1, 2, 3, 4, so on to 13. A represents even numbers, B represents 1, 5, 8, and 9. So again, U being the universal, it's all numbers under consideration. And then finally, cardinality. Quickly, or on your own, you can put me on pause. I want you to find the cardinality of each of these examples. I'm going to say T, where T is equal to the number of days in March. X, such that X is the odd numbers from 1 to 15, and then S, where S is odd numbers divisible by 4. So if you've thought it through, again, this is just the number of elements in each set. So how many days are in March? It's going to be 31. So how many odd numbers are there from 1 to 15? So let's count. Let's see, 1, 3, 5, 7, 9, 11, 13, 15. And since if we're including them, we'll say 8. Lastly, how many odd numbers are divisible by 4? And well, there shouldn't be any, because they're odd numbers. So in this case, we say the cardinality is, let's make that red, is 0. Again, this is an example of cardinality, just how many elements are in the set under consideration. This concludes section 2.1. As always, if you have any questions, feel free to contact me through Blackboard. Have a good day.